Hello, thank you for joining us as we review our case study of an automated Breakpack system in a Walmart distribution center. My name is Amy Greer. My background is in industrial engineering, and I've been focusing on simulation modeling since 2004. I've been with MOSIMTEC since 2013. Scott Ponsford and Sean Martin from Walmart Canada were our project champions on this simulation effort. So a little bit about MOSIMTEC. We've been around since 2011. We're a simulation services provider, really focusing on helping our clients get the most out of their simulation engagements. So whether that be us developing a model and handing that model over to our customers, or us using simulation modeling to run analysis and develop recommendations for our customers. We use multiple software platforms, and as you can see, we work across multiple industries.
Hello, my name is Sean Martin. I'm an engineer and project manager here at Walmart Canada, working in the supply chain and logistics team. Here at Walmart Canada, we have over 400 stores spanning the country from coast to coast, and like our colleagues in the States, we have the same focus on customer experience and providing an everyday low price. Recently here in Canada, we were very proud to announce a $3.5 billion investment in our business, covering an improved customer experience, improved omni capabilities, smarter stores, and notably 2 state-of-the-art automated distribution centers located in Surrey, British Columbia, and a future distribution center in Vaughan, Ontario. This project that we're talking about today is really a precursor to some of those larger automation projects where we decided to install a limited scale automation system in one of our existing regional distribution centers to prove out the value that this kind of technology can have for our business in a way that helps us right away. Working with MOSIMTEC and designing the simulation was something that we were really interested in pursuing because it helped us to kind of challenge the assumptions that are made along the way as you develop this kind of project, along with validating the expected benefits early on rather than waiting for the system to go live. And finally, it helps us just to make sure we're asking the right questions as we develop this model to make sure that we as the end user really understand what's going on behind the scenes in the solution that we're putting into our business. The application for this project was the Breakpack process in our Cornwall Regional Distribution Center. For those who aren't familiar with Walmart's Breakpack process, this is where incoming cases are broken down within the warehouse and sent out to our stores in less than a case quantity. This is typically reserved for those slower moving products where it is either undesired or infeasible for a store to stock an entire case of product on the shelf or in the back room. So they would order it in a smaller quantity and the distribution center would fulfill to them in that way. The problem with our current Breakpack process is, as a distribution process, the orders get fulfilled in the way that they come into the distribution center. So on an outbound container, you can have a mixed bag of product from apparel to health and beauty products to hardware products, all arriving in the same container. The challenge with this model is that it's not friendly to the stores, so the store either has to implement a secondary sort process upon receiving or spend a lot of time moving around the store to find all the right places that they have to be stocked. So some of the benefits with this project is that we can combine the sortation and the fulfillment process into one solution and end up with an outbound tote that is more friendly to the stores so that they can spend their time more efficiently serving customers. One of the challenges with this is there's a balance between carton fill and store friendliness. So we implemented a simple algorithm that allows the totes to be filled to their maximum capacity while still sorting the totes by department so that when they arrive to the store, it's in a way that's easy for them to use. So now that I've covered the Breakpack process and Walmart Canada, I'm going to hand it over to Amy to review the model. Thank you.
So we'll jump in and do a quick demonstration of this model. This was developed in AnyLogic with an Excel front end. I'll just jump in. I'm going to run the model with the animation on so we can kind of step through what's going on. So the model starts with a 2D view of the system. We'll go ahead and go into a 3D view, I think, to explain what's going on in the system. We have the decant area. This is where pallets come in with the individual cases. The cases are opened up and the product is put into product tote. That's the black totes flowing back through here. The product tote then goes into storage in the ASRS system. The products could be staple stock. That's things that are just carried in the warehouse and used on a fairly regular basis. Or it could be what we call distribution assembly. So distribution assembly, anything that comes in on one day will definitely be going out the following day. Once the product totes are stored into the ASRS, they will be called out to the pick stations as needed. If you remember, we said we have two objectives here. One is maximize carton fill and store friendliness. So the software actually runs algorithms at the beginning of the day to determine exactly which warehouse pack should go in each order tote. So that's a pre-assignment that's done at the beginning of the day. And then the software also determines when a pick station is available, what order tote should they be working on next, and then pulls out the product totes correctly. So a picker will continue to fill an order tote until it's done and can leave the system. But product totes can flow in and out of the system or flow in and out of the ASRS as needed. They may visit multiple stations throughout the day before they're emptied. An empty tote flow is also something really important in this system. Once a product tote is full or emptied at a pick station, it'll get sent down to the decant stations to be refilled again. If the product tote's not emptied, it goes back into the ASRS until it can be. So once the model's run to completion, the outputs get loaded back up into Excel for Walmart to take a look at. We had a couple different modes. One was a reporting system that allowed us to look at reports across scenario. What I'm sharing with you guys right now is one particular scenario that was run, and we really deep dive into individual scenarios. Before we take a look at the outputs, I'll step you through some of the inputs that Walmart had at their disposal. Demand generation is always important. So we had the ability to change the number of stores that this distribution center might be servicing, along with the warehouse packs per store per day that would get ordered. Once a store had a number of warehouse packs they were going to order for a particular day, the SKU table was used and the velocity on that table was used to determine what SKU was part of the order. There were some additional settings besides just randomly sampling for the SKU. One, in this system, because of planning, we don't have to send out every single thing that a store might possibly want. We can look ahead, send a little more one day, a little less the next day. So within the model, it was reasonable to go ahead and have a range on warehouse packs per day that we would actually try to service. We could adjust the warehouse packs per store. If you don't want to go through and manually change the distribution, we could very quickly add 5 or 10%. We could force the distribution assembly. Anything that comes in one day needs to go out the next day. So we could force that to occur in full case quantities. We could also turn off staple stock or distribution assembly and run those in isolation if we wanted to. We could filter out in the SKU table. We could very quickly say, what happens if I ignore SKUs that have certain characteristics? And we also put a maximum SKUs per day. Because of that distribution assembly, we aren't going to see a little bit of every SKU every day. So this allowed us, in our logic to go ahead and put a maximum so we would see fewer SKUs per day. In addition to the demand inputs, we also had your traditional processing time inputs for the decant stations. This is one example. We could turn the stations on and off. We could have them start later in the day. This particular model, the system was already under construction, so we didn't have a lot of flexibility in the layout itself. The vendor had done some preliminary simulation models to make sure that there was enough capacity in terms of number of stations. And Walmart, with this particular model, was really more interested in fine-tuning how they use the system, you know, what SKUs they put in the system, what replenishment policies should be, those sorts of things. Some of the output reports, we had a lot in tabular format. As we mentioned, department purity was really important on the totes. We could look at ASRS utilization. We could look at that in a tabular form, or also look at that graphically over time. We could look at the overall throughput of the system. We could zoom in on a smaller range of days, and you'll see there's definitely a trend over time within the days. We'll discuss that a little bit later when we go through our key findings. One of the things really important with this system was the store friendliness of the totes. So we could come in and look at how full were our totes and how department friendly were they coming out of the system. One of the features we really liked about this model was the ability to run it in a cartonization only mode. So if I came in and did cartonization only, the model would run through the cartonization logic, because remember, cartonization happens at the beginning of the day. So we would just run the cartonization algorithms to look at how full our totes were and how department pure our totes were. And that was a super fast mode of analysis. We didn't have to run the full discrete event simulation model. And that allowed Walmart to take, you know, a lot of different demands, look at the cartonization algorithm, and determine if it was meeting their needs. So there were two really key findings that came out of this modeling effort. The first was that the ASRS sizing was not the issue it was assumed to be, which was good news for Walmart. It meant they potentially can run more SKUs through this system. However, the overall throughput was lower than expected, and that was due to the empty product tote flow. Initially, straight line calculations had been used, and it really assumed that the pick stations would generate empty totes at about the same rate that the decant stations would need them. However, in the actual system, what happened was at the beginning of the day, this yellow line represents the empty totes that are going from pick stations to the decant station. And at the beginning of the day, we don't turn over as many totes as we do towards the end of the day. This is because the distribution assembly, everything that came in the day before is going out the next day, and the totes are just more full at the beginning of the day. So the system, on average, over the course of an entire day, the pick stations were generally balanced with the decant stations in terms of empty totes needed. But within a day, they were not balanced at the beginning of the day. And this actually put more load on the ASRS because the ASRS had to spend more time pulling empty totes instead of just servicing the pick stations. And that hadn't really been accounted for. So Walmart's using the model right now to test out some strategies for staggering decanting throughout the day because of that empty tote dynamic the model was able to uncover. And they also plan to continue using this model to look at what SKUs they can move over to the automated Breakpack system. There's a Q&A session immediately following this presentation. If you have any additional questions, MOSIMTEC's also exhibiting at WinterSim, so please feel free to stop by our virtual booth if you'd like to chat some more about this particular project.